Hello and welcome back. International A-Level Mechanics M1. A fixed rough plane is inclined at an angle theta to the horizontal where tan theta is equal to 5/12. A particle of mass 6 kg is projected with a speed of 5 meters per second from a point A on the plane, upper line of greatest slope of the plane. The coefficient of friction between the particle and the plane is 1/4. A. Find the magnitude of the frictional force acting on the particle as it moves up the plane. Let's deal with that first before going on to B and C. So here's our particle, and here is the normal contact force, or the resultant force. Here's the normal contact that the particle makes with the plane, and of course this is our frictional force that they talk about, and we can call that Fm, F max. And because these are similar triangles, this angle here, theta, is equal to this angle here. Now if we're moving away from the angle is always sine theta. So this must be, we've got the mass here of 6g newtons, and this must be 6g sine theta. And if we're moving into the angle resolving perpendicular, this has got to be 6g cos theta. So using F is equal to mu n, F is equal to mu n, so F is equal to, or F max is equal to mu n or mu r, whichever you like. We can now find the value of n resolving perpendicular to the plane. So I'm going to say resolving perpendicular to the plane. Tell the examiner what I'm going to do. Resolving perpendicular to plane, what am I going to have? I'm going to have n is equal to, here we go, n is equal to 6g cos theta. N is equal to 6g cos theta. And now they've told me that tan theta here, tan theta, using this information here, is equal to 5/12. Well, if that's the case, I can find the other trigonometric ratios, which is quite nice and useful, because they're telling me that this opposite side is 5, the adjacent is 12, and therefore I can find the hypotenuse. So I know that tan theta is equal to 5/12. They've given me that, and 12 squared plus 5 squared is 169, and the square root of 169 is 13. So that means sine theta is equal to 12/13. Sorry, 5/13, not 12/13, I apologize. Opposite over hypotenuse, so katoa. So is equal to, sine theta is equal to 5/13. Yeah? And therefore cos theta must be equal to adjacent over hypotenuse, which is 12/13. So there we have it, which is 12/13. So that gives me my ratios, and we're going to see how that's going to help us, because look here now, n is equal to 6g times cos theta, and cos theta is 12/13. I substitute that in, I find the value of n, which is 6 times 12, which is 72g/13. And 72g/13 gives you 72 times 9.8 divided by 13, and that will give you the answer of, in fact, I'll just leave it like that. And if I want to find F is equal to mu n, because n we know is 72g/13, so F max must be equal to, and it does tell me, hold on, the coefficient of friction between the particle and the plane is 1/4. So it's got to be 1/4 of n. So 1/4 times 72g over 13. So we go to our calculator and let's get rid of that. And we have 1/4. What's it not working? Let's get going. It's all in real time here. Here we go. 1/4 and then multiplied by 72 times 9.8, and that's equal to 72g over 9.8. So I can put that as a fraction. What happened here? Let's go back. 72 times 9.8 and divide by 13 is equal to, and here we go, which is 13.6. So I can do it straight away. So F max is equal to 13.6. And there's the answer to part A. Part B now, I'm going to resolve along the plane, resolving parallel to the plane. So let's have a look at part B and let's extend it. So part B, it will take some time, this question. You've got to be patient with it. So resolving, I'm going to tell the examiner what I'm going to do now. Resolving up the plane to the plane, to plane, and the resultant is again mu n. So if I do that, so the resultant Fr is equal to, we're using Newton's second law if you're going up the plane. Let's have a look at this. Up the plane, your part B, find the distance AB. We need to put that in here, going up the plane. So this is the particle A, and it's going up the plane to B. So we need to put that in because the particle comes to an instantaneous rest at point B. So when it reaches B, it's come to rest. So we need to find this distance here. So A to B, going up the plane now. So F is equal to MA. So the resultant is F is equal to MA, Newton's second law. So if I do that, I'm going against the motion of friction. So that's minus Fm. So let's write all these forces in. So I'm going minus Fm, minus Fm is equal to, not equal to, minus Fm, and then, let's get rid of that. Go back. So let's start again. Let's do it here. Minus Fm minus 6g. Now again, I'm going away from that. So it's 6g sine theta. So minus 6g sine theta, because I'm moving away from the angle, minus 6g sine theta is equal to 6a. Mass times acceleration is equal to 6a. So therefore, I know that Fm is minus 13.6. Or Fm is 13.6, it will be minus 13.6 minus 6g, and sine theta, going back to our triangle, sine theta was 5 over 13 times 5 over 13, which is equal to 6a. So that gives me A. When you deal with all of that on your calculator, you'll get the answer of A is equal to minus 6.0. to 3 sig fig. I'm conscious of the time, so that's why I didn't bother go to the calculator. It's already been done, worked out. So A is equal to minus 6.03 to 3 sig fig at meters per second squared. So better put that in. Meters per second squared. So that's the acceleration. Now, and that's of course going from A to B. Now, once you've found the acceleration, you can use SUVAT. Now, we have been given, well, we don't know S because that's what we need to find, the distance. We know that the final velocity, because it comes to rest, is 0. And we know that the initial velocity is equal to 5 meters per second. And we know the acceleration is equal to minus 6.03. So we can using v squared is equal to u squared plus 2as. So final velocity is 0. U squared is going to be 25 because it's 5 squared, plus 2 times the acceleration, which is minus 6.03, and s. And that gives you, well, 25 over 12.06. So s will be equal to 25 over 12.06, and s will be equal to 2.07 meters. 2.07 meters. So there you have it for part B. Part C, we're going to need to construct a diagram which is slightly different than our original one. So let's do that, because the situation has changed in part C from my recollection, and we will go to the question again. So let's just deal with that. Oops. Let's just deal with that, and let's have a look again at the question. Part C, the particle now slides down the plane from B at the instant when the particle passes through the point C on the plane. The speed of the particle is again 5 meters per second. Find the distance BC. Now, if the particle is sliding down the plane, let's put the particle in here. Again, here's our particle, and we have the similar situation of our normal contact force. Here we go. There's our normal contact force, and we need the particle. Now, if the particle is sliding down the plane from B, the friction is acting in the opposite direction. So we need to account for that and make sure we draw it correctly. Here you go. And so it's in the opposing direction, and we need to know that our oops, don't know why that has happened. Let's go back and do that again. Yeah, here we go. That's our normal contact force extended, and we need our mass in again. So here we go. Oh, still 6g newtons. We can extend this as well, because this will be the same. Oops. Yeah, there we go. So we got everything that we need, and of course this is our normal contact. This angle again is the same as this angle because of similar triangles. This is 6g sine theta. This is 6g cos theta, and this is 6g n. And this is now the point B, and C will be going somewhere in this direction. So we have all the ingredients, and we're moving now from B to C. So C is let's put C somewhere down here, and we still have the same speed, which is 5 meters per second. So let's resolve down the plane. Let's resolve down the plane. So if I do that, resolve down the plane, I just write it because it's not down the plane. My writing is very bad, I know, but forgive me. I'm trying to help you with the math. We have 6g sine theta. So resolving down the plane, I've got 6g, again, sine theta minus the frictional force minus Fm is equal to, using F is equal to ma, 6a. So I just say using F equals ma, Newton's law. Now I know that 6g sine theta, let's go way back, sine theta is 5 over 13. So 6g times your 5 over 13 minus Fm, and Fm we got to be 13.6. 13.6 is equal to 6a. So again, I'm going to find the acceleration by dividing everything on the left hand side by 6, and I get the acceleration to be 1.50 approximately. And meters per second squared. So meters per second squared. And if the acceleration is 1.50 meters per second to 3 sig fig, I know that the initial velocity, I can say, but at C, V is equal to, the final velocity is equal to 5 meters per second. So I'm going to use again the SUVAT equation using V squared equals U squared plus 2AS. I'm going to say that the final velocity, which is 5 squared, is equal to the initial velocity, because it was at rest, 0, plus 2 times approximately 1.5s, 2AS. So that gives me 25 divided by 3 is equal to S, and that will give me the answer of 8.33. So S is equal to approximately 8.33 meters. And that's it for 13 marks.